Hello, I am John Daniel M. Osmeña from Group 1, and I am here to demonstrate the demultiplexer, specifically the 1 to 4, 1 bit to 4 output demultiplexer. So, here we can see the truth table and the K map of the given truth table of the 1 to 4 demultiplexer. At the first column, we have the input or enabler column. I have mixed the input and enabler columns because they both act almost the same, because when the enabler is zero, the circuit is not functioning, or is considered off. And when the input is zero, the demultiplexer just outputs zero, or basically outputs nothing. And when they both output one, then the multiplexer is on, or outputs a given value of 1 at the selected pin using the selectors 1 and 0 here, these two. So at the second and third columns, we have our selectors, and the last four columns, we have the output. So as we can see here, that when the input is 0, or the enabler input is 0, all of the outputs are 0, because it's either there is no input, or there's no input, or the multiplexer is turned off. So here, when the multiplexer is turned on, or there is an input, we can see here that there are single outputs of 1 each in each output pins or columns, because the demultiplexer just is one to many. It separates it to the one line to many lines. So basically, it activates one output pin at a time, so that you can maybe select if you want to activate this specific the device connected at the output pin F0, or the device connected at F1, and so on. So given here is our K-map. Our K-map for the output F0, F1, F2, and F3. So these are simple K-maps, each having one group of one value of 1, and here are the sum of products each. So now, if we go to our logism map and implement the truth table and K map, so we will bear with me, just move this, and there we go. We will now implement this truth table and K map to the logism program. So first, we have our 3 pins here and our NOT gate. So let's fix our inputs first. So let us draw a line for our first selector and our selector 0, and convert them to our inverter using our inverter. And there we go. Move this here. And let's now first implement our first K map for the output F0. So for our output F0, let's get an output pin, label it F0, and place it at the side first. And now let's get from our library, Lab1 library, our AND gate. Make it horizontal, place it here. And now our sum of products here is, there we go. Our sum of products here is S S1 prime, S0 prime, E. So we will utilize the uh, primed versions of our selector pins. So we will get S1 prime, first pin is 0 prime, and that, and use this over here. And this is our F0. Copy this, put it aside. That's our F0. The circuit will not output anything here because our enabler or input has no value or is valued at 0. So there will be no output of 1 or a high value output because our enabler is currently 0 and our demultiplexer is currently deactivated. So for our second pin, our F1, here, we have S prime and S0 E. It's S1 prime. Utilize it here, top, then S0, and our media. And I'll copy this here, and its label. Now for our F2 pin, F2 output pin, we have S1 and S0 prime. Let's get our S1 and 0 prime and our input enabler here. There we go. Our pin. And lastly, we have our FT output pin, which has non all non-prime versions of our input. So we will use this one, S0, and enabler. Wrong input. That's output pin. Here and again copy the pin. And let us now just tidy this up. There we go. So basically, this is what our 1 to 4 demultiplexer looks like. So if we switch this to anything, it won't output anything because the demultiplexer is deactivated or it has currently no one input. So if we activate the demultiplexer or input this, by the way, this I mix the enabler in the input because it's only 1 bit, and with 2 bits and many and 3 bits and so on. The enabler and incrementer cannot be mixed together because the enabler is a 1 bit value that only mean the its main function is to only activate and deactivate the multiplexer. Here we can interchange with them because the input and the enabler are both 1 bit values. So that's why I mix them together here. So if we, for example, do this output of 0, the 100, it outputs 1 here at the 0 pin, and 101 outputs the 1 at the first pin, and the 110 outputs at the second pin, and 111 outputs at the third pin. So basically, this is our 1 to 4 demultiplexer applied. So again, I am John Daniel and Osmeña from Group 1. Thank you for watching.